If you're an automation engineer, you know the ultimate headache. How do you upgrade a complex running system without hitting that big, expensive stop button? Well, in this explainer, we're diving into exactly how to do that, upgrading a live system on the fly with zero downtime. Just think about it for a second. Maybe a sensor is failing, and the new one you've got has totally different parameters. Or maybe you need to expand and add a whole new I/O station. Normally, that would mean shutting everything down, right? And when we're talking about large-scale industrial plants, stopping production isn't just a little hiccup, it's a massive deal. We're talking huge restart costs, lost product, and really complicated procedures. You just know there has to be a better way. And there is. It's called CiR, which stands for Configuration in Run. Basically, it's this incredible feature that lets you make pretty significant hardware changes to your automation system while, and this is the key part, the CPU stays in run mode the whole time. All right, so it sounds amazing, right? But like any powerful tool, CiR has its own set of rules. Let's break down what you can do, and just as important, what you can't. So here's the cool stuff. CiR gives you a ton of flexibility. You can add or even remove entire I/O slaves. You can pop new modules into existing stations, or you can change the parameters of a module that's already in there. The main limitation? It's all about the periphery, the I/O. You can't, for example, mess with the core CPU properties or change the DP master system itself while it's running. Now, to pull this off, you do need the right gear. CiR is built for your more robust systems, specifically the S7-400 standard CPUs and some of the H series, the fault-tolerant ones. And on the software side of things, you'll need to be running PCS7 version 6.0 or something newer. Okay, enough theory. That's great, but let's get our hands dirty. How do we actually switch this feature on? Let's walk through activating CiR right in the hardware configuration. First things first, pop open your HW config. All you need to do to start is click on the Profibus DP Master System line, the one you're planning to work on. Simple as that. Now, just a quick right-click on that line, a menu will pop up, you're going to navigate to Master System, and then click Activate CiR Capability. You're basically telling the system, hey, get ready for some changes later, and boom. Once you do that, the software creates these two really important placeholders. You get a CiR object on the master line and a CiR module on each of your existing slaves. Think of these as little reservation signs, saving space for future hardware. And this is where you get to plan for the future. Just double-click on that new CiR object, and you can tell it exactly how many new slaves you want to reserve memory and bus resources for down the road. And here's the magic moment. You download this new setup to your controller and look closely. The CPU state is still run. You've just prepped your entire system for future mods without a single second of downtime. Okay, we're all set up. Let's really put this thing to the test. Now we're going to see just how easy it is to add new hardware to a system that is live and running. Remember that CiR object placeholder we just made? Well, if you want to add a whole new ET200M slave, it's literally as easy as finding it in the hardware catalog and dragging it right onto that object. It just snaps into place. And watch this. The system is smart enough to keep track for you. If you check the properties of that CiR object again, you'll see it's already counted down. We started with 10 available slots, and now we have 9 left. Pretty cool. All right, to make it official, you just download the new configuration. And I'm going to sound like a broken record here, but it's important. The system stays in run the entire time. We just physically expanded our network, and we didn't have to stop a thing. And hey, this doesn't just work for big components. It works at the micro level too. Need a new analog input module? You find it, and you drag it right onto that other placeholder we saw, the CiR module that's sitting in the slave station. But CiR isn't just about adding and removing hardware. This is a big one. You can change parameters on the fly. Let's say you need to swap a sensor, and the new one uses a 4 to 20 milliamp signal instead of plus or minus 10 volts. No problem. You just change it right in the module's properties while everything is live. And one last download to lock in that parameter change. So let's just pause for a second. We just added a slave, we added a module, and we changed a critical parameter, all without ever hitting the stop button. That right there
is the power of CiR.
So we've seen the how. Let's zoom out and talk about the why. Why is this capability such a total game changer for anyone working in industrial automation?
It really all boils down to this. You dramatically reduce your planned downtime. You get this incredible flexibility to adapt your system as you go. You slash those massive restart costs, and it just makes the whole process of upgrading faster and, frankly, a lot safer.
You know, the best way I've ever heard it described is like this. Using CiR is kind of like a surgeon performing a minor but critical operation without having to put the patient fully under. It's targeted, it's precise, and you avoid all the risk and recovery time that comes with a full shutdown.
So I'll leave you with this question to think about. In your plant, on your line, what could you fix? What could you optimize? What could you expand if you knew you'd never have to stop the process to do it? The possibilities are pretty staggering.
What if you could perform open-heart surgery on a factory while it was still running? I know it sounds pretty much impossible, right? But it's actually a daily reality, all thanks to a technology that lets these massive, complex systems get upgraded without ever hitting the off switch. So let's dive in and see how this thing keeps our modern world humming.
Okay, so picture a huge chemical plant, or maybe a non-stop manufacturing line. If you need to shut one of those down just to add a single new sensor, it's not like flipping a light switch at home. The cost to stop and then restart these super intricate processes, we're talking it can run into the millions. It's a massive headache that industry has been trying to solve for a long time.
And that right there, that's the big question. What if you just didn't have to stop? Well, the answer is a technology that was designed specifically for this problem. It's called Configuration in Run, or CiR for short, and it is the key to making changes on the fly.
So what exactly is this CiR stuff? Well, at its heart, it's all about making what engineers like to call hot changes. Basically, modifying a system while it's live and operating.
I mean, the clue is right there in the name. CiR gives an engineer the power to change the actual hardware configuration of an industrial control system, the factory's brain, while it's in run mode. And that means no stopping, no downtime, just continuous, uninterrupted operation. It's a game changer. And this right here shows the difference perfectly. On the left, you've got the old way, a clunky, stop-everything, multi-step process. But on the right, the CiR way, it's just one single, elegant step. You just download the change to the running system. This isn't just about convenience. It's the difference between hours or even days of downtime and just a few clicks of a mouse. Okay, so being able to add new hardware to a live system just out of the blue, it sounds a bit like magic, right? So how is it even possible? Well, the secret isn't some kind of trick. It's just really clever planning. The best way to think about it is like reserving a parking spot for a friend who's coming over later. Even before they arrive, you've already got a space saved just for them. CiR does pretty much the same thing. During the initial system setup, you basically tell it, hey, I might want to add more hardware here down the road, and the system goes ahead and pre-allocates all the resources it's going to need, like memory and addresses. And these digital parking spots are called placeholders. You have a CiR object, which reserves space for a whole new device. Think of that as the main connection point. Then inside that device, you can have smaller reservations called CiR modules for individual little parts, like a single sensor or a switch. They're just empty slots, really, ready and waiting to be filled. And here's what that actually looks like in the software. When an engineer adds that main placeholder, the CiR object, to the network, the system is smart enough to automatically create those smaller CiR module placeholders inside any connected devices. It's like it's thinking ahead, getting everything ready for whenever you want to expand in the future. All right, enough theory. Let's actually see this thing in action. We're going to walk through the exact steps an engineer would take to add some new hardware to a totally live system. Okay, so first things first, you've got to enable the feature. Activating CiR is a super simple 3-step process right inside the configuration tool. It all starts with telling the system which part of your network you want to make flexible. So the whole thing kicks off with just a single click. The engineer highlights the main communication line that they want to prepare for future changes. And then
It really is as simple as a right click. A little menu pops up, and the engineer just selects Activate CiR Capability. And with that one click, boom, that entire line is now ready to accept changes on the fly.
All right, so CiR is active, the system is prepped and ready. Now for the main event. Let's do a real hot change and add a brand new component to the network, all while everything keeps on running. And just look at how easy this is. The engineer finds the new piece of hardware they want to add over in the catalog, and then literally just drags and drops it right onto that CiR object placeholder we made earlier.
And check this out. The system is so smart that it's keeping track of its resources in real time. You can see right here in the Properties window, after we added our new device, the number of available, guaranteed slots for new devices went from 10 down to 9. It just knows.
Okay, this is the last step, and it's the most critical one, pushing that change to the live controller. When the download window pops up, the engineer just has to make sure that little box for download station in run mode is checked, and then they hit OK. The new configuration loads, the new hardware comes online, and the whole process just keeps on chugging along.
Now, this technology is incredibly powerful, but it's not a complete free-for-all. To keep the system stable and safe, there are some very clear rules about what you can and what you cannot change while it's live. Let's break those down.
So here's what's fair game. You can add or get rid of entire devices or the individual little modules inside of them. So this means you could, say, add a whole new set of temperature sensors to a pipeline, or you could tweak the settings on a motor controller that's already there, all without a shutdown.
Now for what you can't do. And this is for really important safety and stability reasons. The core infrastructure is totally off limits. Think of it like a running car. You can change a tire while it's rolling, maybe, but you can't start rewiring the engine's main computer. So you can't modify the main CPU, you can't touch any of the modules in its central rack, and you can't alter the fundamental communication rules for the whole network. It's also really important to know the difference between standard CiR and its more powerful big brother, which is called HCIR. That's used in high-availability, redundant systems. And as you can see in this table, while they can do a lot of the same things, HCIR lets you make even more fundamental changes, like modifying CPU parameters and memory in a live system, which is absolutely critical for those applications that can't fail no matter what.
At the end of the day, this technology is about so much more than just convenience. It really represents a fundamental shift towards continuous improvement. The ability to adapt and evolve and upgrade a system without that massive cost and risk of disruption. It really leaves us with a powerful question. When you can upgrade the very core of our industrial world without ever having to hit the off switch, what does that truly make possible?
All right, so let's talk about something huge. Massive industrial systems. Think chemical plants, giant manufacturing lines, power stations. These things are built to run 24/7, nonstop. But what happens when you need to upgrade them, or add a new sensor, or maybe expand part of the line? You can't just turn them off. Shutting them down can cost millions. Today, we're going to look at the incredible technology that makes the impossible possible.
And that really is the multi-million-dollar question, isn't it? For decades, the only answer was, well, you don't. Or you plan for a ridiculously expensive and complicated shutdown. But the system we're talking about today, it answers this question in a completely different and, frankly, revolutionary way. Just look at a place like this. In a complex plant, every single minute of downtime is just money pouring down the drain. We're talking lost production, sure, but also these incredibly complex and costly restart procedures. It's a logistical nightmare. The real challenge is, how do you modify the very heart of the system while it's still beating? And that right there brings us to the hero of our story, a technology called CiR. CiR stands for Configuration in Run, and it does exactly what it says on the tin. It's a method for changing a system's hardware configuration, its brain and its entire nervous system, while the main controller, the CPU, stays in run mode, fully operational. The best analogy? It's like performing open-heart surgery on a factory while it's still running at full speed. And this right here illustrates the difference perfectly. On the left, that's the old way.
You have to select your new part, compile everything, stop the entire system, download the new setup, and then restart everything. It's a messy, disruptive process. But on the right, that's the CiR way. You select your new module, and you just download it directly. No stop needed. The process is clean, it's streamlined, and the plant just keeps on humming.
So the basic idea here is that CiR isn't for setting up a system from scratch. No, it's designed to build upon a system that's already up and running. Once that initial setup is done and the CPU is in run mode, CiR sort of unlocks. It gives you this incredible new layer of flexibility to make changes on the fly. So what's actually in this toolkit? What kind of power does CiR really give you? Let's take a look at what you can do. The capabilities are really impressive. You can add or remove new input and output modules, especially from the super popular ET200M family. You can add or even get rid of entire distributed I/O units. Engineers call them slaves. And this might be the most flexible part. You can reparameterize existing modules. So let's say you're swapping an old sensor for a new one with a different measurement range. CiR lets you update the software to match it, all while the system is live. You'd think a process this powerful must be incredibly complex to pull off. But no, it's actually designed to be surprisingly simple. Let's walk through adding a new I/O unit, a new slave, in just 3 steps. Okay, step 1 is literally a drag and drop. That's it. You just find the new hardware component you need in the catalog on the right. In this case, it's an ET200M unit, and you just pull it over and drop it onto the special CiR object in your main configuration. Now, step 2 is where the magic happens. The system automatically puts this CiR module into the new slave you just added. This thing is basically just a placeholder. Think of it like reserving a parking spot. It tells the system, hey, something is going to go here eventually, so it saves all the resources and address space you'll need, but without disrupting any of the cars that are already parked and running. It's so clever. And here it is, the final, most crucial step. You download that modified configuration to the controller. See how the download and run mode option is selected? That's the whole point. You hit OK, the changes are sent to the CPU, and it never, ever has to stop. The plant just keeps on producing. It's incredible. Of course, a system this powerful has to have some ground rules. You can't just do anything you want. So let's look at the specific requirements and, the limitations you need to be aware of. First off, you need the right gear. CiR is made for a specific set of Siemens S7 400 CPUs. Both the standard ones you see here and the extra reliable H versions for fault-tolerant systems. You also need to be running at least PCS7 version 6.0, and this is a big one. Your user program has to be written so that it doesn't just panic and shut everything down if it sees a small error. It needs to be robust enough to handle these changes. So, knowing what you can and can't do is key. As we've seen, you can add and remove I/O modules and units, you can change their settings, that's all fine, but you can't make fundamental changes to the core system. For instance, you can't just change the properties of the main CPU itself. You can't add a whole new master network or change core things like the communication speed. Think of it like this. CiR lets you redecorate the rooms, but you can't mess with the building's foundation. Now this is one of the most important safety features baked into the system. When the CPU does that tiny little pause to integrate the new stuff, what happens to all the physical things out in the plant? The motors, the valves, the heaters? This is the brilliant part. They all just hold their last value. Everything stays stable. It prevents any weird, erratic behavior during that brief update. And how long is that brief interruption? Typically, 1 second. That's it. That's the default time the system pauses its processing to safely load the new configuration. For a massive industrial process, a 1-second pause where all the outputs just hold steady is, for all practical purposes, seamless. And for those systems that need even higher levels of reliability, there's HCIR. The H here stands for high availability. So while standard CiR is already super powerful, HCIR just takes it a step further. When you use it with those fault-tolerant CPUs, it lets you do even more, like changing the CPU's parameters or even adding and removing modules in the main controller rack. It's really the next level of on-the-fly flexibility. So let's bring this all together. Why is a technology like CiR so important? what does it all mean for the future of these industries?
Here's the main takeaway. CRI is not just another cool feature. It represents a fundamental change in philosophy. It's moving industrial automation away from these rigid, fixed systems that are hard to change and pushing us towards a future that is way more flexible, more resilient to change, and ultimately a whole lot more efficient. It lets our biggest and most important plants evolve and adapt without that massive penalty of downtime.
And that leaves us with a pretty mind-bending final thought. We've just seen how it's possible to do the equivalent of open-heart surgery on a running factory. So if we can already do that, if we can reconfigure the actual physical hardware of a massive industrial plant while it's still operating, what does that mean for the next generation of automation? What in the world comes next?